Sorry, just charging for the next person. Died in the middle of the afternoon. All right, I'm Mel Steffens. Can't hear me? Can't hear me. Is that why we went to the mic? How about now? Same. What's again? Same. Oh, again? Okay, gotcha. I know where we're going after this. Okay, well, I'll just make sure I use the classroom to speak loudly. All right, I'm Mel Steffens. Very happy to be invited to discuss this paper, which is I found quite interesting. I'm maybe back to the book rather than give us a at the beginning. Let me just get to the point. All right, so many times when we're doing applied work, right, everything is going to hinge on having a valid instrument. Of course, having tests for whether or not we actually have a valid instrument, right, those are few and far between, right? So there's the classic Houseman over-identification test, right, which works great when you have multiple instruments and constant treatment effects, but usually we don't have multiple instruments, and we left constant treatment effects, way behind a long time ago, so usually not what we're thinking about. Then more recently, there's Kitagawa and related papers, which have tried to give us a way to think about instrument validity, when we have heterogeneous treatment effects, right? But again, there's limited work on this. So what do people do? So a lot of times what people do in practice is say, well, I've got this falsification test, right? And so what is a falsification test? Well, so for example, maybe there was something that happened prior to the intervention, right, that presumably should not be impacted by the intervention. Right? And these things have been around for a long time. For example, there's a Heckman-Hotz paper in JASA like '89, which talks about this in not really a formal way, but kind of talks about doing this. And people have done these things for a long period of time. Right? And that's one thing this paper points out, in fact, is that people have been doing these things for a while, but we just don't have a systematic framework for really thinking about doing falsification tests. Right? So what this paper is going to do is to try to give us some very systematic guidance for thinking about falsification tests. One thing people, of course, have done is use rhetorical skills. Those have been fantastic in trying to motivate, like, oh, yeah, you should do this, or oh, yeah, you should do that. I thought if I left that on the slides when I wrote them late at night, you'd think I'm way too cynical, so I got that part off of here verbally. But we know a lot of rhetorical stuff is what goes on, right? Okay, so in the paper, what they do is they first survey the empirical literature. They look at a decade's worth of papers in top 5 econ journals, right? And it turns out that when people are using instruments, roughly half of the papers have falsification tests. More precisely, 51% they found. And then of these, they note that there's 2 types of falsification tests that show up, a fair bit. Right? The first is what they call a negative control outcome. Right? What's a negative control outcome? We'll have a more formal definition later, but for now, think about this as there's some outcome that we think should not be correlated with the instrument. Right? The instrument is affecting this outcome. We're like, oh, I didn't want to do this. By the way, the paper which is fantastic, has tons of examples littered throughout. So you're going to see lots of examples coming up. And credit where credit's due. I did not come up with any of these examples. I'm just borrowing the examples that they have, spread throughout the paper, which I think that, collectively do a great job of illustrating all the points that the authors are trying to make here. And so you got these outcomes that should not be impacted by the instrument. And it turns out roughly 75% of these papers have these placebo tests, these falsification tests that use these negative control outcomes. Then there's negative controlled instruments, right? These are maybe alternative instruments that shouldn't be correlated with your outcome of interest, right? And if you find evidence of that, you'd be a little bit nervous about what you're doing, and about a quarter of papers do this. Now, these should not add up to 100 because actually there's some overlap. You can sort of do both, right? So you can do both a NCO and an NCI in the same paper, right? So there's other types of tests that are out there, but these are the main 2 categories, and they're going to focus their framework on thinking about these 2 categories, right? And often these variables that we're using in practice, of course, here's the key thing, right? These variables are not the unobservable that's really causing the problem, right? Instead, these variables are actually proxies for the variable that's causing the problem, right? And so since we have these proxies for something causing the problem, we have to think about, oh, well, we're using these proxy variables, not the true variables. And so the framework that they build thinks about, okay, we're using proxies instead of the real thing. Does that add an extra layer, extra set of wrinkles for trying to determine what is a valid NCO or NCI and what is an appropriate falsification test? Right? So that's the way that they go here. Right? So roughly the outline of their paper and of my discussion, right, is first is let's try to identify the problems that we've got at hand. And we're going to illustrate these, they are illustrating these using DAGs, these directed acyclic graphs, which Judah Pearl is most noted for using a fair bit to try to think about these. I think they're actually work really well in this situation of highlighting what's going on. So you're going to see those a lot. Again, I stole these from their paper. So I can illustrate as we're going ahead. And so there's going to be lots of things bouncing around. And so you'll see lots of figures to hopefully keep us all anchored on what it is that we should be anchored on. Right? And these DAGs are going to help us think about these negative controls, right? And why they're helpful. Right? And then what they're going to do is they're going to formalize everything. They're going to provide a theoretical framework. And again, this I think is really the key contribution of this work. It's giving applied researchers a way to think about these falsification tests, right? So again, people have been doing these things for a long time, using their rhetorical skills, and what we're doing here is saying, oh, let's be a little bit more. And again, the we is royal, not me. Right? And then they're providing, and thinking about these things they call alternative path variables and these negative control variables, which we will define, but are really at the heart of everything. So the alternative path variables, these are the unobservables that are important, and these negative controls are the proxies that we'll use for the falsification test. And then at the very end, we'll have some suggested procedures for researchers. How can we, as researchers, apply what they have proposed in practice, right? And what are some suggested testing procedures, right? And then what do we do when we find things that may be good or bad? Okay, so I don't know if I started a few minutes late or not. I can try to hit the 11:50 target to keep us at lunch on time, or whatever works. Oh, okay, perfect. Okay, all right, perfect. All right, so here is, up until a few days ago, I think I understood what was going on with these things. I mean, I know Heckman wrote an article a year or two ago trying to think about all of these things together, and I keep telling myself I should read it and understand how the DAGs work in a much deeper level of understanding than what I have. But I think even with my superficial level of understanding, you will be able to understand what's going on here, right? So this is showing 4 variables. Let's start with the first 2. So y is the outcome of interest that we all care about. X is going to be the treatment variable, right? And if we're in a world where it was just simply X and Y and there was no W here, this would be really easy, right? This is, undergrad econometrics for 90% of the semester, where you just say, look, we've got the 0 conditional mean assumption and we're going to run this regression and we can believe everything that we estimate. And at the end of the semester go, oh, by the way, there's this endogeneity thing, right? And that endogeneity thing, that's the W here, right? So W is this confounder, right? The confounder is influencing both the treatment variable X as well as influencing the outcome of interest. Okay? So what do we do to try to deal with this problem? Well, I'm preaching to the converted here, but nevertheless, just to build up to where they like to go, is I need some instrumental variable, right? They use Z, the traditional instrumental variable in this notation, right? And so the key thing here is while we've got this confounder that's influencing both X and Y, and it makes us nervous about the 0 conditional mean assumption, right? Instead, we use the instrument, right? And as long as the instrument is influencing X, then what we can use, of course, is the variation in X, driven by variation in the instrument to identify the impact of X on Y. Right? So this is the way we overcome the problem. All right, so what could possibly go wrong? Well, of course, lots of things could go wrong. I'm sure many people have had this go wrong on them at halfway through a project, a couple of years in, whatever it is. So it's never fun when something goes wrong, but it's nice to have some falsification tests to try to think about the problems that can arise. Right? So they're going to think about two types. Well, again, we're going to have these. We're actually going to have a 2x2 thing here. Okay, so the first two things is we're going to have these negative control outcomes and these negative control instruments, which I mentioned before, but I will give you their formal definition in a moment. The other thing is that they're thinking about two ways that we can have problems, right? The first of these two ways is outcome independence, if outcome independence goes wrong. What's outcome independence, right? It's what's sometimes referred to as ignorability, right? But it's this idea that assignment is as good as random, right? So that the instrument is not affected by any other variable, right? That is also going to be affecting the outcome. That fails and outcome independence fails. The second thing is the exclusion restriction. This is where, so rather than, so you think of the first one, the outcome independence, there's some unobserved variable that is impacting Z and also impacting the outcome. Whereas you could think of the exclusion restriction is that Z is not just affecting X, but it's affecting some other variable as well, and that in turn is also affecting the outcome. All right? And again, be more precise about this in a moment, but that's the general thing. We've got these two things that we need, right, for it to be the case that the only way that Z is impacting Y is simply through the treatment X. Okay? So outcome independence, exclusion restriction, and we're going to interact that with the two terms that I had before to have actually 4 sets of things we need to worry about overall. Okay, so like I said, I've stolen some examples. Here's the first of the 4 stolen examples, and we're going to go through these 2x2 cases. Okay? So the first is thinking about this negative control outcome, or the use of a negative control outcome, right, when we're worried about outcome independence. So this is taken from a paper which is about the impact of Fox News on Republican vote share. Right? So here, the outcome Y is Republican vote share, right? X is local Fox News viewership, and then they need some instrumental variable to move around Fox viewership. What do? Well, they say, listen, on your cable channel, right, where they place Fox News might impact how likely it is that you watch Fox News, right? So if you turn on TV and the cable channels start at 2 and then go up, well, if it's the 2, it's the first thing that you see, maybe you're more likely to, oh, look at that. Versus if I've got to go searching way down the channels, then maybe I'm not going to do that, or I'm less likely to do that. So that's their instrument here. So this is the setup. What we're worried about is what's on the slide here, this U1. What's the U1? Well, this is a measure of like how conservative is the local area. Maybe it's the case that the broadcaster is like, yeah, we have a lot of people that are really interested in Fox News, and they'd love, just to make their life easier, let's make it the first channel, right? Let's not make them work their way through. So we're a little nervous about that, right? And so that would be a case, oops, press too many buttons here. Go back. All right, go back one more. So that would be a case where we would violate this outcome independence assumption. And so what could you possibly do? What would be a potential falsification test here? Well, you might think, listen, button's right eventually. There we go. Listen, what I can do is I can look at Republican vote share prior to the advent of cable TV and just ask the question, if it's the case that local conservativeness, which is not observed potentially, right? We don't truly observe that, but I've got this proxy variable, the proxy being live Republican vote share. I can ask, hey, in places where lots of people in the past voted for the Republican Party, is that where they put Fox News way down on the channel count, down by 2 or 3 or something like that? Right? And that's the idea. So this would be this negative control outcome, so it's another outcome, and you would use this for your falsification test. Right? Next thing, and I will try to go through these. Like I said, a lot of this is going to be pictures and just to give everyone on the same page, because just to understand the framework here, right? So there's this well-known Ingris and Evans paper about the impact of family size on labor supply. So the outcome is labor supply. The endogenous variable is the number of kids you have. And then they famously use the sex composition of the first two children, right, with the idea being that people have a gender mixed preference. So if the first two kids are the same gender, people are more likely to have a third child. Right? So this is a case where the concern, and we have here now Z affecting the unobservable U, and this is where it's a little bit more hand-wavy than all the other examples, because maybe we observe this, right? But what maybe you worry about here is that, now I have, kids of the same gender versus different gender. I can think differentially about, say, hand-me-downs, right? So, right, because if I can share the clothing from one kid from another, I don't have to go out and buy new clothes, right? And so maybe that impacts how much I actually have to work, right? Actually, I remember reading this again. I remembered Aaron Yelowitz had a job market paper, which was, I believe, was in public housing, where depending on the gender mix of your kids, it depended on how many bedrooms that you actually got in public housing. If they both were the same gender, with two, you got a 2-bedroom place, one for the parents, one for the kids, but you got a 3-bedroom place, right? So then I thought, oh yeah, of course, other people, you might have a bigger house because maybe you want to separate your kids. So there's other things. This is the issue here, right? And actually, in a JL article, well-known, Hess, Rosenzweig, and Wolpin looked at, say, clothing expenditures as an NCO. Okay, hopefully everyone's on the same page with me right now, right? They've got a couple other examples. So what I've shown you, I keep wanting to push left and right, and that's not the way to work on this thing. Right, so what I've shown you here are negative control outcomes, right? So these are outcomes that should not be affected by the instrument. If they are, we might be kind of worried. Right? These are where we have alternative instruments. Okay, so the first one is by Nunn and Kwan, where they're interested in the impact of food aid from the U.S. on civilian conflicts in other countries. So Y is conflicts, X is food aid. It turns out that when you have shocks to U.S. wheat production, we've got lots of extra food lying around, so we more likely to send that food aid to other countries, right? But when do we have these shocks? Well, we have these shocks when there's these unobservable weather conditions, right? Now, I don't know everything about, global weather systems and interactions, right? But the concern that they have here is that, well, maybe there's, the weather systems are a particular way in the U.S., maybe, so if it's rainy here, maybe it's drought somewhere else. Right? And the drought somewhere else means that, that could be really what the conflict is, right? So these unobservable weather conditions could be related to U.S. wheat production. And so what they do is they say, oh, you know what? Oranges also in the U.S. should be, impacted by favorable weather conditions. And, if we use oranges as an instrument, right, that shouldn't work because, of course, that should not be part of food aid because it's not used in the whole food aid process. And then I've got one more for you, but in the interest of time, I think I'll skip over this one, right? But the key thing, like I said, this is a 2x2, right? The NCO, NCI, and is it outcome independence? Is it the exclusion restriction? Okay, so that's just to give you a sense of what's going on and to see here are some situations that they've uncovered and said, yeah, people have been doing this before, right? They hadn't been using the language that they're introducing. And the question is, how can we systematically be thinking about falsification tests, right? So what's going to make for a great falsification test? So they have a couple of assumptions. The first is outcome independence, right? This is just a formal way of writing down what we said before. The instrument's uncorrelated with the potential outcomes. Right? And then there's the exclusion restriction, right? That is, the potential outcome as a function of your treatment does not vary with the instrumental variable Z. And so these together give us the standard orthogonality condition that we're used to seeing. Right. So again, there's many types of falsification tests. Again, there's going to be two broad categories. There's the negative outcome controls and the negative outcome instruments. I'm going to discuss each of these in turn. It's just a lot easier to do it this way. But I was like, oh, I realized when I had like almost one slide for every minute of my discussion, I was like, this isn't going to go well. That's okay. I want to make sure I reflect the paper. Okay, so the path, right? So remember, what do we want? We want the only way that z affects y is through x, right? So the thing is, there's something out there in the world, this alternative path outcome, right? This is a variable that's going to be associated with the outcome, and the concern is that's also associated with the instrumental variable. So for example, in the Fox News example, right, the alternative path outcome would be this variable right here, the local conservativeness. We don't observe that. We instead use this in the testing, right? So the problem is going to be related to this, but we're going to use this in testing. That just means we need to be cautious about our testing because we really want to test this. We can't treat this as if this is the real unobservable. We have to remember it's a proxy, right? And that just helps. You know, that's the key thing here, really, for thinking carefully about testing. So there's a couple of definitions that we'll see here. The first is that a variable is going to be an alternative path outcome, right? Like local conservativeness. If it's the case that the following is true, that once we condition on this unobservable u, then the instrument's orthogonal to the potential outcome. This is just another way of saying that the only way that we could potentially violate outcome independence is through this unobservable here. Because once we condition on unobservable, that's the problem. We condition on that, this will be okay. Right? That's but this is also very important, right? What it also, the first thing to take away is that, look, we can't test this by using the NC, the negative control outcome and conditioning on that, because that's just a proxy for this, right? So if you said, oh, what I'm going to do is I'm going to condition on, say, local Republican vote share, lagged vote share, and then test whether or not the instruments uncorrelate with the outcome, that would be flawed. That would not get at this. You really need to see the unobservable, right? So this is helpful, but it also tells us what we can't do, right? So right now it says, look, this would not be a good falsification test to say, oh, it's good because you've got to condition on the right thing. And then the second thing is that the result is that if we've got a valid instrument, then the instrument should be orthogonal to this unobservable. I know it skips the definition 3, but this skips the order in their paper. And so what's definition 3 is that if a variable is a negative control outcome, right, if there exists this unobservable such that once we condition on the unobservable, the negative control outcome are uncorrelated, right? So again, if it's the case that, or they say the contrapositive for some of the stuff they do, but if it's the case that the instrument is correlated with this negative control outcome, if it's the case that where you are on the cable channel, where the Fox channel is correlated with lagged vote share, it's got to be due to this local conservativeness, right? That's going to be the problem here. And then this, say, the Fox News, the Republican vote share has got to be a good proxy for this unobserved local conservativeness, right? These two things need to be correlated. That's what's being said here. Right? And so all this structure is telling us is that basically if the instrument is correlated with a good proxy, right, then we're going to have problems. Right? But the key thing is finding a good proxy in this situation. Right? So, again, in this example here, right, what's an example of a negative control outcome that's going to work, right? So the position is C, we've got the local conservativeness, right, as the unobservable, and then we've got this lagged Republican vote share, right? And this would be something that would work in this situation. And any situation, any association, excuse me, between the instrument and this negative control outcome has got to operate through local conservativeness. Okay? So what their structure is saying is that, look, if you can identify what the problem is, we can think of a proxy that can go along with that problem, right? Then we can think of what a valid test would be for testing whether or not we've got this particular type of potential problem, this particular correlation between Z and U. Let me give you an example that they have in the paper of one that does not work so well. So this is a case where Y is respiratory emissions to a hospital, X is air pollution, and then what you propose to use as your negative control is non-respiratory admissions, right? Because you might think, well, look, I've got some instrument is affecting air pollution. That's great, and there's been work in this doing this. The problem is that of course, why am I worried about these non-respiratory emissions? Well, what could happen is when air pollution gets really bad, what that does is suddenly we fill with all the asthmatics go to the ER, right? And that just crowds out other people from going to the ER and actually getting admitted. Okay, so this would be an example of a situation that doesn't work so well in this case. But I was supposed to have some comments as I go through here. One of the things I'd like to say is that I think their framework works really well for identifying situations where we've got negative control outcomes that will do a very good job. It's hard to, if something does not fit into their framework, right? It's sort of like one of these things where things are positive, things match their framework, that's awesome, we can use it. If it's the case that something does not fit in their framework, like I tried to play around for a long time trying to think of how could I make this one actually work out and show you why it doesn't work so well. It's not so easy to demonstrate that, but it's a lot easier to say something actually falls within their framework, right? That's not it's more of a feature of what they're doing than I view it as being a bug. Overall, I view what they're doing as really good. Okay, so here's the theorem. What they have is they say, look, in this situation, what can we do if we have negative control outcomes? What we need to do is just simply ask, is the instrument correlated with a negative control outcome, either by regressing Z on the negative control outcome or vice versa, depending which way you want to do it. If, for example, you had multiple negative control outcomes, you could put them all on the right-hand side at once and regress Z on that. That's something that's perfectly okay. It's also, when they talk about in the paper, relatively straightforward to extend this to including covariates in their model. They talk a bit about that in the framework as well. The key thing I really want to highlight is they also have these negative path, the alternative path instruments, right? This is where you have a variable that's associated with the instrument, and the concern is also associated with the outcome. Here, the example again is the food aid example, where you've got these unobserved weather shocks. We're using, say, wheat production as the instrument, and the alternative instrument would be orange production, which should not be associated with food aid. They have the same setup here. Just in the interest of time, one of the key things that happens here is that in this particular case, you end up conditioning on the instrument Z, right, in the testing. And so the big thing about this approach here is that the unobservable should not be correlated with Y once you condition on the instrument Z. So the difference between I want to push both sides of my other remotes I have, and this one is totally different. But the difference is that in this case, what you can do is you want to see if there's a problem with regressing Z on this the negative controlled outcome here, right? Because there's that unobservable U right there, and that's the pathway that's having Z affecting to this, and we want to see if that correlation is 0. When we're in this situation here, what we're worried about is that the unobservable is correlated with Y, and so the way to deal with this is to have a test of like, well, is our negative control instrument correlated with Y, and it should not be correlated with Y. But the key thing to do that is you also need to control for the instrument Z in this case when you're doing it. So for example, if we're asking whether or not orange production is correlated with civilian conflicts, right, it's important to condition on wheat production when you actually do that. If you don't, then the actual testing procedure will be flawed, and that's something they highlight here. So I think I'm probably at 1 minute. Okay, very good. So I'll just jump to what do they do? Right? So they say, so they give a lot of guidance for researchers, and maybe I will let Dan talk about what the guidance is rather than trying to do it in my last minute. Right? So overall, they have really good guidance for thinking about falsification tests. I really think this should prove really useful to applied researchers. I feel like it's something that editors and referees are going to make all of us do when we have instruments going forward. Is it'll give the referees something for them to latch onto when they're making suggestions for what we should be doing. But that's a good thing, especially for them. I think that's it. I think Dan will probably touch on the other stuff.
Okay, thank you very much. Can you hear me?
Yes.
Okay, thank you very much for this presentation. So we always joke that this is a paper written by a synthetic econometrician consisting of a health economist, a labor economist, and a statistician. And we were basically coming to it from the pain of trying to do this and not seeing how exactly we should do it. And I think what we're trying to do here is, I think Melbourne presented this, to help everyone think through what they need to do when they want to do these falsification tests. And I want to abstract a little bit from the details because of the time constraint, and just tell you that when we started doing it with surveyed literature, we were thinking we might find these kind of issues, that people are doing wrong things, and then they get kind of valid instruments go through. But in fact, we realized, and in that case, I think it's not just good for referees, it's good for the authors, that some of the mistakes, which I'm going to touch on, are actually sort of rejecting valid instruments. So it's kind of more of a problem of kind of specificity than sensitivity. So what we're basically, just going back to this one of these kind of basic examples, what we're trying to say here is that, when you think about your, in this case, independence assumption for the, Fox newspaper, you kind of first identify the thing you're worried about. So the first step in the guidance, okay, what is the concern, right? So here the concern is that conservativeness that connects Z and U. And we call that an alternative path variable because it's, the way we teach it to undergrads is that there's a prohibited path if U is indeed connected through the red arrow to Z. There's a bad path that violates the instrument from Z to Y. However, we usually, if you could observe things, we'd control for them. So that starts to be a problem when you can't observe stuff. And then we look for proxies. So NC is the proxy. It's a negative control outcome because the way we'd run it is usually plug it in instead of Y. I want to say a bit more about that. But basically, why is it a good proxy? Well, it needs to be kind of sensitive and specific. It needs to be the case. So we characterize, I'm not going to repeat again, and it's on the paper, like what would make that kind of threat what it is. And again, it should be a threat because, it is the threat. So if you condition any things are fine, you can't because it's unobserved, so you look for the proxy. And the proxy should not be directly connected to the instrument because you just get a non-specific test. You just get a connection. If there was a connection between NC and Z, well, you see the wrong kind of outcome for your test, but actually it could be fine, right? So you want it to be just through the U. And also, so basically the test would be once you sort of look for correlation between Z and NC. If it exists, then the red line exists and you're in trouble, right? So I think I encourage you when you read the kind of paper, I think thinking through this kind of notion of sensitivity and specificity of your NC test is really helpful. And so just sort of in a nutshell, and so I think that, and the way I would sort of, just to clarify the air pollution example, here this happens. Why? Because the missing link, so again, the respiratory admissions, non-respiratory admissions sounds like a great idea. I mean, they shouldn't be related to smoke or whatever, air pollution, right? All these kind of wind direction instruments and things like that. But actually, there's a link between air pollution X and the NC, which is non-respiratory admissions for congestion. So now it's not specific. The fact that you see NC connected to Y doesn't tell you anything about the dashed line. So that's how you rule that out, right? So you kind of, and we do everything in potential outcomes, so you can basically just kind of check the sensitivity and specificity of your potential proxies. So the thought process here is quite simple. So what's your path? What is on it? Is it really that thing that is the threat? That's unfortunately the thing you can't observe. So the thing that you can observe, is it really such that, you know, a connection between it and the outcome, or in the case of a negative control instrument, connection between it in, between this in the instrument and for NCO, and with the outcome for NCI, is it such that when this connection exists, we really learned about the problematic path, or there could be other ways in which they could be connected, and then it basically just throw the baby with the water and kind of, you know, you have a valid instrument which you rejected. So two kind of common mistakes we found in implementation are one, that when you do these NCI tests, so again, going to the weather example, where was that? Well, I'll just say it, I don't know where the slide is. Is it? Sorry. Well, never mind. So, I think it was before, give me a sec. Very beginning. Right?
There twice. You can do it back or forward.
No, that one? Yes, that, right? Okay, so here, the story is simple, okay? You need to control for the original instrument. And, you know, Marcel, just let me reiterate. That's a problem, and people don't do that. And they just reject valid instruments, and maybe not. You know, we surveyed papers that got published and discussed, but could be a power issue, right? Maybe they were lucky to be underpowered, ran the wrong test, and that didn't reject. But with sufficient power, you should reject if you correlate, you try to correlate. So there's the oranges are not used for aid. We try to account for the unobserved weather. What they do, and then they correlate orange production with conflict. But I mean, if the weather thing drives both, then you see this path going through the unobservable U3. And so orange production would be eventually correlated with conflict. So it's conditional on wheat production that it shouldn't be correlated to be informative of that path, right? So lesson number one, if you flip your instrument with something else, which is, by the way, something development economists do much more than health economists. So I think we can kind of, we surveyed a lot so people can learn from each other. And that's another, I think, something we're trying to do is list all these different ways people think about falsification and kind of show you a menu of options. And basically, we really need to control for this instrument. And again, it gets a little bit more nuanced. We discussed the paper. Maybe sometimes you don't, but you know, these are additional conditions. But as a general rule, you need to conditional on the instrument for these NCI tests to be valid. The other thing that we highlight in the paper, we'll just get to, and I know we're going to lunch, so I'm going to be brief, is that the way we implement the test is related to, is often very much related to the fact we're doing 2 SLS. So people take something like the reduced form, you know, and then plug the NCO instead of the instrument. That's your usual, they plug the NCO in terms of, instead of the outcome, and that's your usual balance test, right, that you see, or they flip and plug the instrument. And the problem with that, the potential problem with that is by taking the linear form, we now test more than just the 2 assumptions that, you know, we want to test. Now, whether this is a good or a bad thing kind of depends. So let me kind of briefly state how. So basically, if you're doing a 2 SLS and this is an NCO, then there's this Torgovitsky Mogstad, I forgot the other author's paper recently showing that you really want saturated covariates and kind of linearity in covariates for you being able to kind of interpret QSLS as causal. And they show that if they're like, if you have a non-saturated incovariates model, then things could go wrong for your interpretation. So in that case, you actually want linearity, and by using a linear functional form in your ANC test, you're now testing three things. Like what people call instrument exogeneity, which is truly like the exclusion restriction and outcome independence, and what they call rich covariance assumption. So you might reject for either reason, but it's kind of important to remember that you're also testing linearity, which in this case you want to test. And if you fail, well, maybe it's just a specification and not some big problem with the instrument. So that's one way it kind of be helpful to think about the kind of implementation. When you're doing a negative control instrument test, then you swap the instrument for something else. Think about the oranges. You need to plug in the original instrument. But then you're testing some weird assumption about the outcome being rich in the covariates, linear in the covariates. That's not necessary. So if that kind of test fails, you could go for non-linear tests, flexify things a little bit, and you're still fine. So this kind of, I think, 2 points, or maybe just to kind of wrap up, this we will try to guide you, and there's much more in the paper, obviously, about how to think about these tests. We often, I think, might help you not reject valid instruments by being more specific about the test. And if you have to take two things, that is that remember that, like if you're doing an NCI test, plug in the original instrument, condition on it, and then remember that you're not just testing fundamental instrument assumptions, but also functional forms. So that might give you some leeway in case the test rejects. Okay, thank you very much.
One actual question, no comment. Maybe two questions and actual questions. No. Yes.
So a lot of this is about whether to control for stuff or put on the left. And I think probably my favorite paper title is this paper by Fishkin and Schwant called "Poorly Mapped Confounders Are More Useful on the Left-Hand Side Than the Right." I was wondering if there are places here where you can kind of choose to do it one way or the other.
Yeah, we have a discussion about that. We show when it's equivalent. The main thing I think is that often people, because it was so ad hoc, like someone in the seminar would tell you, what about that? You would do that before you submitted, or for you would say, what about that? You would add that before the revision. People sort of leave, and we show that kind of, we go for replication packages. People leave good NCIs or NCOs in the data. So when you have many, and again, you thought about them and they're good in the sense we define, then like probably testing them jointly in an F-test is better, which you could only do in one way, and then sort of it gives you. So basically, doing an F-test is better than doing multiple testing because it's just more efficient. We have some discussion of power, but it's not for before lunch. I'm happy to talk after. Other questions?
Yeah, we have another time for another question. Yeah.
So motivated as someone who finds complicated math scary. Suppose I'm willing to write down the DAG. Is it clear how I should figure out if there's a test I can run, and if so, what the right test is?
Yes, actually, if you're really committed to a DAG, I mean, one way you can read our papers is that you could, if you're committed to a DAG, then it kind of gives you all the answers, right? We're not usually, I think, as applied economists, very much committed to one DAG. So that helps you, like, if you have several DAGs in mind, you could. But if you were to be committed to one DAG, then you could make it an algorithm, right, of which test you run and stuff like that. And actually, this is one of the appendix. An appendix in the paper sort of discusses that all through DAGs and exactly is doing that. So I refer to that.
People are compliers. They're asking questions. Any other questions?
It's the lunch break, yeah.
So if I look at the DAG you wrote for the Fox News,
Yes.
is that easy to? I guess what I'm confused about why you wrote it that way, because I would think W is the local conservative.
Yeah, maybe that's not great here.
That's the.
It could be related. It could be something else. That we don't preclude you from being related to W. So in a way, it's not a great example. That it doesn't have to be local conservativeness that you're worried about. So it's maybe a little bit specific to that example.
Okay.
But in general, there could be an association between that threat and the original confounder. But it doesn't have to be.
But you do need to think carefully about what W is versus what U is to be doing this at all, right?
Yes, well, it depends whether it's NCI or NCO, and we're very precise about that. I think that example is a bit misleading, but yeah, it's obviously the case that the relationship might matter. Yeah, good observation. Thank you.
Any more questions? We have a little bit of time. Okay. So thank you so much.
Thank you.